All right, so a couple of reminders here, guys, about your final exam. Okay, final exam, January 23rd, okay, 1 o'clock in this room. Okay, be here. The door will open at 12:45. Okay, you need to come with some pencils, some pens, and your calculator. That's it. Okay, that's all you have to bring. Okay, if you bring anything else, it can be, something to drink or something to eat. Okay, nothing else can come in here. Remember, all mobile devices, okay, have to be in your locker. Okay, all of that kind of stuff. Okay, so the final exam, same format as a unit exam. So there's some multiple choice and there's some written response. Okay, it's going to be very familiar to you. I'm going to ask the same things on the final exam that I asked on the unit exams, and then I asked on the assignments, and on the quizzes, and all of that kind of stuff. So one of the places I would start, if I were you, would be to look at your quizzes. Okay? You probably throw them away. That's fine. Okay? If you haven't, good. If you have, it's okay. Don't throw stuff away. Yeah, whatever. Better. But here's what you can do. If you go into Power School, okay, you can click on your individual assignments. Okay, so if you click on a quiz, in the notes for the quiz will be 2 links. One link will take you to the quiz questions. The other one will take you to the podcast of the quiz. Okay, so you can try the quiz again, see, write down all your answers, and then watch the podcast and see if you did it right. Okay, that would be what I would do to review some of the basic chemistry stuff like naming compounds, and writing reactions, predicting reactions, balancing reactions, mole equation. Okay, those are kind of the big ones that would be in the written response section of the test. Okay, I'm going to ask exactly the same things in the written response of the final that I did in the written response of the chemistry exam. That was balancing, writing and balancing and predicting chemical equations, and mole equations. Okay, now I just don't ask as many. Okay, like on your unit exam, I asked 7 balancing questions, 4 write, predict, and balance questions, and then I had 4 mole equation questions. So obviously I don't have that kind of time on the final exam. Cut that in half. Okay, I think I have 3 balancing, 2 reaction, and 2 mole. Okay, so same things, just less of them. Okay, I'm also not going to ask the hardest ones I can think of. All right, now this is just my philosophy on final exams. Not everybody agrees with me. I like to think of those people as wrong. Okay, but I don't think the final exam is the place to ask the hardest question I can think of. What makes a final exam difficult is the volume of material that it covers, not the level of difficulty of the questions. I asked you some hard questions on your unit exam. Okay, I'll ask similar questions, but of a slightly lower level of difficulty. All right, so things we talked about in the chemistry unit. Okay, naming compounds. Got to be able to do that. If you can't name compounds, how can you possibly hope to write chemical reactions? Okay, you can't. It will be hopeless. So make sure you know how to name compounds. It's that fundamental skill of the whole unit. Okay, you also wouldn't be able to do a mole equation calculation because I just write the name of the thing out and you have to figure out the formula and you can't do it. Right? Well, we don't want you to be in that situation. Make sure you've gone over naming compounds. Okay, writing formula for compounds. So those things go together. Naming compounds, writing the formula for compounds. Got to be able to do that. Remember, there are a couple of tricks when it comes to ionic compounds. The molecular ones are pretty straightforward. Prefixes. Kind of go with that. But with the ionic compounds, remember we got to do the swap and drop. We do that even if we have a polyatomic ion. And we also have the special metals that have more than one possible charge. Okay, so as a quick review here, okay, if I have, hold on.
No, I have 3 questions.
Okay, so quick review here, guys. What if I have this stuff here? What is that? Iron trichloride. Wow! Guess who needs to study their naming? Everybody. All of you. Okay, how many possible charges does iron have? More than one. More than one. It can be a 2 or a 3. No. If every chlorine is a -1, how many negative charges do I have? 3. Okay. Ionic compounds always have to have a net charge of 0. So what's the charge on this iron? 3. There's only one iron, so this is iron, Roman numeral 3. Oh, I gotta sync the board. Fluoride. Look where I'm writing, look where it's showing up. Okay. Is that ringing a bell?
Yeah.
It's better. If it doesn't, you better study. Okay. So, make sure that you go over that naming stuff. Also, if I have, let's say, something that has a polyatomic ion in it, like, let's say, what would the name of that be?
Oh, copper.
Copper 2 sulfate. Okay? Copper can be a 1 or a 2. Sulfate's always a -2. How many sulfates are there? 1. Okay, there's 1 sulfate here. So there's 2 negative charges. That means this copper has to have a +2 charge. This is copper 2 sulfate. Okay, so we best review that. That's the kind of thing that could cost us big marks on a reaction or mole equation question. Okay? So it's not just about being able to manipulate the mole equation. I know you guys can do that part. It's the simple things that trip us up. Okay? You have all been exposed. Okay? So, okay. Lesson 12 in your notes package on reactions. That is writing chemical reactions, predicting chemical reactions. Okay? Knowing the 5 reaction types. Okay? Got to be able to do that. I could have multiple choice questions saying, which of the following is a combustion reaction, A, B, C, or D? Okay? Or obviously in the written response, I will have situations where you will get a chemical reaction, just the reactants, written in word form, not in formula form, and be asked, write out the entire reaction, predicted products, balanced, reaction type identified. Okay? Got to be able to do that. You were asked to do that in the chemistry unit, so you're going to still be asked to show that you know how to do it. Okay? So let's say I had this, for example. Okay, what kind of reaction is that? The synthesis reaction. Yeah. Okay, 2 elements reacting. What are they going to form? 1 single compound. Okay. How do I figure out what this compound looks like? I got to do swap and drop the charges. Right. This is an ionic compound. It's got a metal and a non-metal. See all these little things? Right. It's the little things we forget. Okay. Charge on nitrogen is -3. Charge on lithium is +1. Drop and swap. Li3N. Now I got to balance the whole reaction. Okay. So I'm going to need a 2 here to balance my nitrogens, and a 6 here to balance my lithium. Okay. The eyes are getting wider. Let's try this one. Okay. What kind of reaction is that? Double replacement. What happens in double replacement reaction? Metals switch. Okay, so calcium is going to end up with hydroxide. Iron is going to end up with chlorine. Okay. What's the charge on calcium? 2+. Okay, charge on hydroxide? -1. What do I have to put around polyatomic ions?
Brackets.
Right. Okay. Iron has more than 1 possible charge. Which one am I using? 3. I look back over here. Okay? Tells me on the reactant side which one I was using. Okay, so this is going to be FeCl3. Now I need to balance the whole reaction. I'll start with hydroxide because we're supposed to start with the highest number. Okay? So there's 3 over here and 2 over here. So lowest common multiple is 6. Okay? 3 times 2 is 6. 2 times 3 is 6. Okay? That's going to give me 2 irons That gives me 6 chlorines, 3 calcium, it's found. Okay? All right. So a few things to practice. That's okay. Yeah, it's okay. All right, so things like that, definitely going to be on there. Make sure you review how that stuff works. Okay? All right. Mole equation. Okay? So you'll get the mole equation. It's on the back of your periodic table. You've got to have a Avogadro's number. It's on there as well. Okay? Make sure you know that stuff. Okay?
Letters mean again?
Number of moles. N is number of moles. Little m is mass in grams. Big M is molar mass. That's when we add the atomic masses from the periodic table. Okay? We'll go over an example or two here in a minute. You need Ab's number if I ask you to calculate the number of particles, or I give you the mass. I give you the number of particles and ask you to calculate the mass. Then I need Ab's number for that. Okay. In lesson 4, we went over properties of compounds, and then we did a lab. Okay, where we use the physical properties of compounds to identify them. There are a number of multiple choice problems to do with the properties of compounds and that particular lab. Okay, so make sure you go over that stuff, okay, because there could very easily be a multiple choice question about, you have an unknown compound with the following properties, what is it likely to be? And, you can identify it as ionic and whatever. Okay. All right, so make sure you know that. Make sure you know stuff about solubility and the polar nature of water. Okay, we had a written response question on the chemistry exam, okay, about cleaning water, okay, and using a double replacement reaction that would produce a precipitate that was not soluble. It combined reactions and solubility and stuff like that. Okay, there could be not necessarily a written response question, but a couple of multiple choice items that are designed around that idea as well. Okay, so make sure you understand your solubility stuff, and make sure you understand the polar nature of water, because that comes up not only in chemistry, but again in biology. It's how plants transport water. That with osmosis is what moves water up the tubes, the xylem tubes. Okay, so that's going to be an important concept as well, so make sure you go over that. Okay, that's again going to be like multiple choice stuff. Okay, so in the written response, okay, obviously you're going to have to balance. Okay, you're going to have to predict and balance a reaction and do mole calculations. I already told you that. Okay, three balancing, 2 reactions, and 2 mole equations. Pretty sure that's the way I set it up. All done? Okay. Right, so things to remember here, guys, with the naming, okay, remember that ionic compounds have a metal and a non-metal, okay, whereas molecular compounds are made of just non-metals, okay, you're going to have prefixes in them, okay, in the molecular compounds names, okay, and things like that. What would this stuff be called? Sodium carbonate, yeah, okay, this stuff would be iron. Got to figure out which one. Okay?
Oh, yeah. That's number 7.
Oxygen's a -2. 3 times -2 is -6. That means I have to have 6 positive charges coming from 2 irons. Each iron will have a charge of? Iron 3 oxide. Okay? Gotta be able to do that, guys. Guarantee you there will be some like that on your final exam. All right, what would we call this stuff? Dinitrogen trioxide. Okay, good.
Do we have to go like 8 and 9 and stuff like that for names? For like 3
No, I don't think I made anything that big. Okay, write the formulas for those 3. Give me a second on that. See how much you remember. Okay, so first one, is it ionic or molecular?
Ionic.
It's ionic, okay. Lithium is Li, nitride is N, okay, and this is actually one that was in the equation I did just a minute ago. -3 plus 1, drop and swap, Li3, N for that one. Triphosphorus tetrabromide, tri means how many? 3. Okay, bromine, Br, tetra means 4. Okay. Would I ever reduce a molecular compound? No. Would I reduce an ionic one?
Yeah.
Yes. Okay, so for magnesium oxide, so Mg is a 2 plus, magnesium is or oxygen's a minus 2, so when I drop and swap, that'd be 2 and 2, which I can reduce to MgO. Okay. So expect that those kind of things will obviously be on the final exam. Okay, try those two. What the formulas for those? They both have polyatomic ions and Roman numerals. Okay, so for copper 2 sulfate, so this is copper with the 2 plus charge. That's what the Roman numeral tells us. It doesn't mean there's 2 coppers. It means it's 2 plus. Okay, and sulfate is SO4, which is a minus 2. So those cancel. There's our formula, CuSO4. Okay, and then nickel hydroxide, nickel 2 hydroxide. So that'll be Ni, the 2 plus, hydroxide, okay, which is a minus 1. So when I drop and swap, I'll need brackets around the hydroxide with a 2 there. Okay? Got to be able to do that stuff. Okay, if I'm balancing that reaction, what do I balance first? Chlorine is the only thing that's out of balance. Okay, so I'm going to put a 2 there, but when I do that, it gives me how many sodium? 2. Done. Okay, balance what's in the highest number first. Okay, remember that the exception to that rule is combustion reactions. There are 2 rules governing the balancing of combustion reactions. Balance in what order? Alphabetical, and the rule of 2, which says that in a question like this, where I have an even number of carbons, I start with a 2. All right. 2 times 2 is? Okay, so I need a 4 here. 2 times 6 is? 12. 6 times 2 is 12. Okay, everybody all right with that? All right, now I'm going to balance the oxygens because I'm balancing in alphabetical order. 4 times 2 is 8, plus 6 more is 14. 7 times 2 is 14. Okay, now let's balance. Should you expect to get a combustion reaction? Yeah, if I'm only picking 3, yeah, I'm thinking you're going to get one or the other of a single or double replacement, a combustion, and then something else. Okay. Okay. What about that one? What should I start with? I could start with sodium. Yeah, I could start with that. What's the lowest common multiple of 2 and 3? 6. Okay, so I need to put a 2 here, which happens to make my nitrogens balance, so that's a good sign. Okay, and I need to balance my magnesium, so I need to put a 3 over here, but that's not going to work, is it? Okay, so I've got to do something else here. Okay? Yeah. Okay, so what I'm going to do is I'm going to, pardon me, do the magnesium first. Yeah. Okay, so I'm going to put a 3. No, I put a 3 in front of that before. That didn't work. Okay, I have an odd number here. Okay, and that's going to give me a problem, right? I've got an even number on this side, and I've got an odd number on that side, okay, and that's giving me trouble. So what I want to do is this thing here that gave me that odd problem, right? I want to, oh no, it didn't.
Yeah,
I had that right.
Yeah, you did.
And I looked at it, and that's wrong.
I was just confused. That's right, because all you have to do is put the 3 in front of the MA.
See, I should have drank more coffee.
That coffee takes everything.
You should be proud.
Yeah, so it's cool.
Works. Don't listen to me. I mean, what? Okay. So yeah, that's balancing. Be better at it than your teacher is. Okay. So mole equation problem. How many moles of sodium sulfide are in 250 grams? All right. What should I write first?
Given.
Okay, my givens. I know little m, 250 grams. And I know the material is sodium sulfide. That's Na with S, but sodium's a minus 2. So this will be Na2S. So I have to calculate what about this? Molar mass. 22.99 times 2 plus 32.06. 32.07. What do you guys have on yours? You guys have 32.07. Okay. All right, so I've got those, and that'll give me my molar mass. So 22.99 times 2 plus 32.07. So 78.05 grams per mole. All right, I'm trying to find the number of moles. Well, the mole equation finds that without even having to be manipulated, as long as I have mass and molar mass. And I do. So all I have to do is plug in my numbers. 250 grams divided by 78.05 grams per mole. Okay, the grams will cancel, and I'll be left with, so 250 divided by, so we have 3.2 moles, right? We only have, oh, we have 3 significant figures, so 3.20 moles.
Do we have to write the 0 at the end?
Yeah, 3 sig figs. Sig figs, sig digs, significant digits, significant digits. Okay, is that ringing a bell? I'm going to go over the other ones too. The other ways to do mole equations. Like that one. It's almost like I had this plan. Okay, what's the mass of 11 moles of dinitrogen hexafluoride? Okay, so what did the question give me? It gave me the number of moles, 11. Okay, it told me the material, dinitrogen hexafluoride. Okay, so that's going to be okay. So we got 14.01 plus 19. Sorry, this is times 2, and this is times 6. All right, so 142.02 grams per mole. Okay, so I'm looking for the mass. So I have N equals little m over big M. I need to find little m. So what do I do with big M? Multiply both sides by it. Okay, so that's going to give me 11 moles times 142.02. So we only have 2 significant figures here, so that'll be 1.6 times 10 to the 3 grams. Okay. Good. Try this one. This one involves Avogadro's number. Okay, remember, Avogadro's number is 6.02 times 10 to the 23, and it represents the number of particles in 1 mole. Okay, I'll give you a minute on that. All right, so we're told that the material is calcium chloride, so that's CaCl2. That's where most people would screw this question up. They'd forget to drop and swap, and they'd have the wrong formula, the wrong molar mass, blah, 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 go downhill from there. Okay, so we got 40.08 plus 35.99, right? 45, 35.45. Okay, and that's times 2, so we got 110.98 grams per mole. Okay. So what we've got there now, and we also know the mass. Okay, we know the mass is 175 grams. Here's what we have to remember. This is the number of particles in 1 mole. I'm looking for the number of particles in some other number other than 1 mole. Can I calculate the number of moles here? Yes. Okay, that's what I want to do. If I know the number of moles, I can multiply that by Avogadro's number, and that will tell me how many particles I have. All right, so we're going to have 175 grams, okay, divided by 110.98. 175 divided by 110. 98. Well, what you got? Okay, so we're looking at 1.57 moles. Now, I'm going to multiply that by Avogadro's number, 6.02. Second function, hit the comma button, take 23. So we have 9.49, because we have three significant figures. 9.49 times 10, was it 24? Times 10 to the 23 molecules. Okay, if you're given the number of molecules and asked to find the mass, you take the number of molecules and divide by Avogadro's number. Okay, that would be like that one. Okay, and I have the solution still on there for that one. Yeah. Okay, hey, listen up there, guys. Tomorrow, I'm going to do the unit exam review for Unit 4, okay, and then you'll have some time to work on that or work on final exam stuff. That'll be your choice. I would recommend Unit 4 exam review, okay. Wednesday is your unit exam. Thursday, I go over that unit exam and biology. Friday, I go over physics. That's it, okay, then we're done. All right, remember that during final exams, if you are needing to see me for help, you need to email me first and let me know when you're coming in. I will let you know if I'm available. Okay, if I'm supervising an exam, then I'm not available. Okay, but if I am, I will tell you where to meet me. Okay.